Welcome to the deep dive. We take complex topics and really try to boil them down for you so you get the key ideas fast.
That's the plan.
And today we're tackling something it's fundamental to how the web works, even though you might not see it directly. It's called cross-origin resource sharing, CORS for short.
Yep. CORS. And we've dug into some good stuff for this. A technical glossary explaining the terms, and also a more detailed article really laying out CORS policy. Solid sources.
Right. So our mission for you today is simple. Get a really clear, practical handle on CORS. We want you to understand, what it actually is, why it exists, which is super important for security, and how it affects you online every day.
Even if you're not a developer.
Exactly. Even if you're not coding.
Yeah.
Understanding CORS kind of pulls back the curtain on some of the web's hidden security mechanics.
It really does.
Okay, so where do we start? To understand CORS, we first need to talk about the rule it modifies, right? The same origin policy.
That's absolutely the foundation. Yeah.
Right.
The same origin policy is like your browser's default security setting. It's there to stop, say, a malicious website you visit from suddenly reaching out and grabbing data from your online banking tab without permission.
Okay, that sounds important.
It is. It basically says a web page or script can only freely access resources, data, images, whatever, if those resources come from the exact same origin.
And origin isn't just the website address like example.com. It's more specific.
Yeah, a bit more specific. An origin has three parts you need to check. The protocol, so HTTP or HTTPS, the domain name like example.com, and the port number.
The port number. Like, is that always visible?
Not usually. Web browsers use default ports like 80 for HTTP and 443 for HTTPS, and they hide them. But if a site uses a non-standard port, that becomes part of its origin.
Okay, so https.example.com page 1 and https.example.com page 2. They're the same origin.
Correct. Protocol, HTTPS, domain, example.com, and the default port, 443, all match.
But https.differentexample.com is obviously different.
Yep, different domain.
What about http.example.com versus https.example.com? Just the protocol change?
Different origin, protocol mismatch. Or https.example.com.a0a0, that different port number makes it a different origin too.
Got it. So the same origin policy is pretty strict. One of the sources use this analogy, like your household kitchen utensils.
Yeah, I like that one. Think of your website origin as your house. The same origin policy means only people in your house can freely use your forks and knives, keeps things tidy, secure.
Right. But websites do need to share things sometimes, like my weather app needs to get data from a weather service, which is definitely not in the same house. So how does that work?
And that's exactly where CORS comes in, cross-origin resource sharing. It's the mechanism that allows for controlled sharing between different origins.
So it's the way to safely break the same origin rule.
Basically, yeah. It lets websites grant permission to other websites to access their resources. It's like borrowing that cup of sugar from your neighbor.
Okay, the neighbor analogy, I like it. You're not giving them the keys to your whole house.
Exactly. You're just specifically allowing them to borrow that one thing, the sugar. CORS lets a server say, okay, you over there at that specific origin, you're allowed to access this specific resource.
So how does that permission slip actually get passed around? Walk me through a typical cross-origin request.
Okay. So let's say your site, your-website.com, wants to fetch some data from an API at api.example.com. Different origins, right?
Right.
Your browser makes the request, like any web request. But critically, it adds an extra piece of information, an HTTP header called origin.
So it says, hi, I'm calling from your-website.com.
Precisely. That origin.https.your-website.com header goes to the server at api.example.com.
And the server sees this.
Yep. The server receives the request, sees the origin header, and then checks its own rules, its CORS configuration. It asks itself, am I configured to allow requests from your-website.com?
Okay. And if the answer is yes.
If it is, the server processes the request and sends back the data. But crucially, it also includes special CORS headers in its response. These headers basically say, yep, I'm allowing this.
And the browser checks those response headers.
It does. That's the final check. The browser looks at the response headers from api.example.com. If they contain the right permissions, like saying your-website.com is allowed, then the browser passes the data along to your website's code.
But if the server doesn't send the right headers, or sends headers that don't allow your-website.com,
then the browser blocks it. Even if the server actually sent the data back in the response body, the browser will see the missing or incorrect CORS headers and refuse to let your-website.com access that data. It throws a CORS error instead.
So the browser is the ultimate gatekeeper here.
Exactly. The server makes a decision, but the browser enforces it based on those headers.
That corporate office visitor analogy from the article really helped clarify this for me. Can you recap that?
Sure. Think of your-website.com as you, a visitor, trying to get into the office building of api.example.com. The origin header in your request is like showing your ID at the front desk. The server at api.example.com is the receptionist checking the visitor list. That's its CORS policy. If your origin, your-website.com, is on the list for the resource you want,
then you get a pass.
Right. The server sends back the response with CORS headers, which are like your visitor badge. The badge might say, okay, you can access the lobby, or maybe you can go to the third floor.
And the browser.
The browser acts like the security guards. They look at your visitor badge, the CORS headers, and make sure you only go where the badge allows. If the badge is missing or doesn't grant access, the guards stop you. That's the CORS error.
That clicks. Okay, so these visitor badges, these CORS headers, let's unpack the important ones. The glossary mentioned access control allow origin as key.
That's the big one. Yeah, it's the most fundamental. The server puts this header in its response, and its value says who is allowed.
So it might be really specific.
It could be. The server could send back access control allow origin .https.trusted-partner.com. Only requests originating from exactly that site would be allowed by the browser.
Or there's the wildcard option, right? The asterisk.
Right. Access control allow origin. That's like the server putting up a sign saying anyone can access this resource.
Like an open house.
Kinda, yeah. It's very permissive. Useful sometimes, like for public APIs, but you have to be careful. You might not always want everyone accessing your stuff, even if it's just read-only data, especially if credentials are involved, which we'll get to.
Right, security implications. Okay, what about access control allow methods?
So web requests have different methods, like ways of interacting. GET is the most common, just retrieving data. Post sends data, put updates it, delete removes it. Access control allow methods lets the server specify which of these methods are allowed in a cross-origin context. It might say, okay, https.your-website.com, you can get data, but you're not allowed to delete anything.
Like the museum analogy, you can look, but not touch, put delete.
Exactly like that. It controls the allowed actions.
Okay. Then there's access control allow headers. It sounds like it controls extra information.
It does. Sometimes requests include custom headers, extra bits of information beyond the basics. Think of things like authorization tokens, maybe X requested with, stuff like that. If your front-end code adds custom headers to its cross-origin requests,
the server needs to explicitly say it accepts them.
Yes. The server uses access control allow headers in its response to list which custom headers it's willing to look at in requests from other origins. If your request includes a header that's not on that list, the browser might block the request, usually after a pre-flight check.
Okay, like telling someone which questions they're allowed to ask.
Good way to put it.
And access control allow credentials. You mentioned credentials earlier.
Right. This one's really important for security. By default, browsers don't send things like cookies or HTTP authentication details with cross-origin requests. It's a safety measure.
To prevent leaking sensitive user info.
Exactly. But sometimes you need to send credentials, maybe to access personalized data on the other server. If the server is okay with receiving credentials from a specific origin, it needs to send back access control allow credentials.
It's true. And the access control allow origin can't be a wildcard in that case, right?
Correct. If credentials are allowed, the allow origin header must specify an actual origin, not the wildcard. It's an extra layer of security. Think of it as needing specific permission to bring your personal ID credentials into the neighbor's house.
Okay. Last one from the list, access control max age. What does that do?
This one's about performance. It ties into something called pre-flight requests, which we need to talk about next. Basically, for some complex requests, the browser has to send an initial check before the real request.
A pre-flight, like checking before takeoff.
Kinda, yeah. Access control max age tells the browser how long, in seconds, it can cache the result of that pre-flight check. So it doesn't have to ask for permission every single time it makes the same kind of complex request.
Like a visitor pass that's valid for an hour.
Exactly. It saves unnecessary back and forth.
Okay, so that brings us neatly to pre-flight requests. You said they happen for complex requests. Our sources distinguish between simple and non-simple requests. What's the difference?
Right. So the browser tries to optimize. For requests that are considered inherently safe or simple, it doesn't bother with that extra pre-flight check. It just makes the request directly and checks the CORS headers on the response.
What makes a request simple? Is there a checklist?
There is. It's pretty specific. A request is simple only if it meets all these conditions. 1, the method must be get, head, or post.
Okay.
2, apart from headers the browser adds automatically, like host, user, agent, the only manual headers allowed are accept language, content language, and some specific values for content type.
Which content types are simple?
Only application XWWW, form Erlang coded, multi-part form data, or TextPlain. These are typically what old-style HTML forms submit.
Got it. So get head, post, only basic headers, and simple content types for PSAs. If it meets all that, it's simple.
Yes, no pre-flight needed in that case.
So anything else is non-simple, like using put or delete.
Exactly. Or if you add a custom header like authorization, bearer, or xcustom info.
Or if you send JSON data with content type.application JSON in a post request.
Yep, that makes it non-simple too, because application JSON isn't on the simple content type list. For any of these non-simple cases, the browser says, whoa, hold on. This is potentially riskier. I need to check with the server first. And it sends a pre-flight request.
And what is this pre-flight request exactly? What does it send?
It's actually an HTTP request using the options method, not get or post, but options.
Okay.
The browser sends this options request to the same URL on the target server. And crucially, it includes special access control request method and access control request headers.
Telling the server what the actual request will look like.
Precisely. It's like the browser calling ahead and saying, hey, I'm planning to send a PUT request from your-website.com to this URL, and it's going to include an authorization header. Are you cool with that?
Like calling the store to see if they take Amex before you drive over.
Perfect analogy.
Yeah.
And the server's response to this options request is the permission slip.
Exactly. The server responds to the options request. If it's willing to allow the actual request, its response must include the necessary access control allow origin, access control allow methods, confirming it allows PUT in our example, and access control allow headers, confirming it allows the authorization header.
And if the server's response to options doesn't give the green light,
then the browser stops right there. It won't even attempt to send the actual PUT request. It'll just generate a CORS error in the console. The pre-flight failed.
Wow. Okay, that adds a layer of complexity, but it makes sense from a security perspective. So thinking about everyday web use, where does CORS pop up most often?
Oh, it's everywhere in modern web development. Probably the most common case is web applications talking to back-end APIs.
Like single-page apps built with React or Vue. Exactly. Often the front-end code is served from one domain, like app.myproduct.com, but it needs to fetch data from or send data to a backend API running on a different domain, like api.myproduct.com or even a subdomain. That's a classic cross-origin scenario requiring CORS.
What else? External services.
Absolutely. Think about any site that shows you, say, real-time stock quotes or weather information or pulls in map data. That data is almost certainly coming from a third-party API on a different origin. CORS needs to be set up correctly on the API server for your browser to be allowed to fetch and display that data.
And embedding things like YouTube videos or Twitter feeds.
Yep. Embedding content often involves iframe elements or scripts loading resources from third-party domains like youtube.com, twitter.com, payment gateways like Stripe or PayPal. CORS policies on those services control whether your website is allowed to embed and interact with their content.
So it really underpins a lot of the interconnectedness we take for granted.
It really does. Without CORS, the web would be much more siloed or much less secure.
Okay, so when things go wrong, we see those CORS errors in the browser console. What does that error really mean again?
It simply means your browser tried to make a cross-origin request, but the response it got back from the server didn't include the necessary CORS headers to explicitly permit that request from your specific origin.
So the same origin policy kicked in and blocked it.
Exactly. The browser is doing its job enforcing the policy because it didn't get the explicit OK via CORS headers. It's like being stopped at that security checkpoint. You didn't have the right badge.
The article mentioned a typical error. Access to fetch at https.abi.example.com from origin, https.your-website.com, has been blocked by CORS policy. Pretty clear message.
Yep. It usually tells you the resource it tried to access and the origin that made the request, making it easier to debug, hopefully.
Okay, so if you are a developer or maybe managing a website and you hit these errors, what are the fixes? It depends on whether you control the server, right?
That's the main thing, yeah. If you do control the server side, like the api.example.com in the error message, the fix is usually straightforward. You need to configure your server application to send back the right CORS headers.
Primarily the access control allow origin header.
That's the first one. You need to set it to allow the origin of your front-end application, example, https.your-website.com. Or if it's a public API, maybe you set it to the Y, but again, be cautious, especially with credentials.
And you might need the other headers too, like allow methods or allow headers.
Definitely, yeah. If your front end is making non-simple requests like put or delete or using custom headers like authorization, your server needs to respond correctly to the pre-flight options request, including access control allow methods and access control allow headers, listing the things you want to permit.
The source had that little express.js code example showing it's often just a few lines of server config.
Often, yes. Most web frameworks have middleware or settings to handle CORS configuration fairly easily.
Okay, but what if you don't control the server? Like you're trying to use someone else's public API?
Then your options are different. First step is always check their documentation. Good APIs will explain their CORS policy, tell you if requests from browsers are allowed, and maybe if you need to register your origin or use an API key.
And if they just don't allow browser requests via CORS?
Then you might need a workaround. A common one is using a proxy server.
How does that work?
Instead of your front-end JavaScript talking directly to the third-party API, which fails due to CORS, your front-end talks to your own back-end server. Then your back-end server makes the request to the third-party API. Since this server-to-server request isn't bound by browser CORS rules, it usually works fine. Your back-end gets the data and then relays it back to your front-end.
So your back-end acts as a middleman.
Exactly. From the front-end's perspective, it's just talking to its own back-end, same origin or properly CORS configured, so the browser is happy. Server-side rendering can also sometimes bypass the issue for initial page loads.
What about those browser extensions or disabling security settings that the sources mentioned for development?
Right. Important warning here. There are browser extensions that can temporarily disable CORS checks, and you can sometimes launch a browser with security flags turned off. These can be helpful only for local development and debugging when you're maybe waiting for the back-end team to configure CORS properly.
But never for regular use or production.
Absolutely never. Using these tools for everyday browsing or relying on users to install them is incredibly dangerous. It completely undermines the security protections that CORS and the same origin policy provide, opening you and your users up to serious risks like cross-site request forgery, CSRF, and data theft. Use them sparingly, locally, and understand you're turning off a critical safety feature.
Okay. Very clear warning. Got it. So let's just quickly recap the core idea.
Sure.
At its heart, the web has this strict same origin policy for security, but we need controlled ways for websites to share resources across origins. CORS is that mechanism.
Right. It's a system where the server uses specific HTTP headers, like access control allow origin, to tell the browser which other websites are allowed to access its resources.
And the browser's job is to strictly enforce those permissions, blocking requests if the right headers aren't present.
Exactly. It enables things like APIs, embedded content, and modern front-end, back-end architectures to work, but hopefully safely.
It's pretty amazing, really, how this intricate dance happens constantly behind the scenes whenever we browse the web.
It really is a complex but essential part of making the modern web functional and reasonably secure.
So maybe the thought to leave everyone with is this. Next time you're online, think about all the different bits of information and functionality converging in your browser: window maps, ads, social feeds, data from other sites. Consider how CORS is acting as that invisible gatekeeper for potentially hundreds of requests. How does knowing about this constant negotiation change how you see that seamless experience?
And maybe what could go wrong if those gates weren't there? It definitely gives you a new appreciation for these underlying security mechanisms.
Absolutely. Well, that was a great deep dive. Thanks for unpacking CORS with us.